Alright, so now we have the powers of iota, which is the power of the imaginary sign. You see, just like we get some principles from indices, the same thing is going to take place here now. When we say the power of imaginary sign, it means that I raised to the power of n. This is what we are talking about. So I can put this here. I raised to the power of n. It can be small letter n, anything. Okay? So this I raised to the power of n has 4 possible outcomes. What we are actually talking about now is that n is greater than or equal to 2. That means the least value is 2 from 2 upward. When n is equal to 2, what will be the result? When n is equal to 3, equal to 4, equal to 1,000, equal to 1 million, what will be the least value of imaginary power? Remember that anytime you are solving problems on complex number, you must ensure that you simplify the iota to its least level. And the least level of any iota that raised to any power greater than 1 can fall out of these 4 results that you're about to see now. Alright? So there are possible 4 results that you have here. So when I is raised to the power of n, you either have I, comma, minus I, comma, 1, or minus 1. These are the possible 4 results that you have. Otherwise, we can shorten these as I raised to the power of n is equal to plus or minus I, or plus or minus 1. What does it mean? It means that I can either be positive or negative, and then 1 can either be positive or negative. So take for instance, you are given I raised to the power of 99. And then you are asked to reduce this to its least level. What will you do? This result here can either fall out to be this, or this. But how will you get there? How will you get there? Listen carefully. Principles are what you need. So in the same vein, if you have I raised to the power of 8964, these have a result that will also fall out of this. So how will I simplify iota when the power is greater than 2 and above? Now let me show you the concept and the methodology to solve problems on this category effectively. Listen carefully. You really need to understand, because by the time we start performing some certain operation in complex number, you need the knowledge of what I am teaching you now to gain mastery. So pay close attention, because when you are able to understand the principles here now, I tell you the truth, you will be able to solve as many problems at your disposal. Now let's get into this. Now, in order to solve problems on these areas effectively, listen to this. There are basically things you need to understand. First is that note that I is equal to the root of negative 1. And then I squared is equal to the root of what? Minus 1. These 2 results are what you need to simplify any power of the iota. Whether it's raised to the power of 10, 20, 80, 150, 200, 600, 800, 1,000, 1,500, any power up to 1 million, 1 trillion. When you understand this and this, you will be able to provide solution to any power of the imaginary component. How? Now look at this. Somebody may ask, how do we get this? Let me quickly prove this to you. Now understand that I is equal to root of negative 1. And then by standard, we take this as I. So anytime you have I, leave it as I. Don't substitute root of minus 1. You only replace root minus 1 by I. But you don't replace I by root of minus 1 most often the time. But let me not go into that. So then we have I squared is equal to, mathematically, this means I times I. You understand? Just the same way, if you have x multiplied by x, you have x squared, or you have a multiplied by a, you have a squared. The same thing, I squared is the same thing as I multiplied by I. Of course, I know that this I is the square root of minus 1 multiplied by the square root of minus 1. And then according to one of the laws in surd, we have that this, as long as this is in the square root and this other guy is in the square root, this is minus 1 times minus 1. Now remember, you don't multiply this. So what you do is that when you have a square root of a number multiply itself in indices, what do? You pick one of the numbers. So the square root of minus 1 times minus 1 is actually minus 1. I hope you understand this. So first, this is it. Multiply by this. Then this to this end, this to this end, applying any of the laws of surd, as you understand, right? Then if you are having issues with surd, you can just check the playlist of our platform and then you're able to get access to multiple content that have been created to help you understand the basis of surd in details. Alright, so this is what we have. Then from here we are going to get it. But in this model, we are not actually interested in proving all of this, okay? But I just want to show you how I raised to the power of 2 is equal to 1. So understand that I squared is equal to minus 1. This is how it is. So you need these two, I and I squared, to solve I raised to the power of n. No matter what n is, no matter how small and how high n is, you get it. So let's begin this. Now, assuming you have I raised to the power of 3, how will you solve this? Then you begin to apply the laws of indices here. Now remember, I raised to the power of 3 mathematically is the same thing as I raised to the power of 2 multiplied by I raised to the power of 1. Otherwise, you can begin to use brackets this way. If I have x raised to the power of 2 and then x raised to the power of 1, in indices, you pick one of the base and then add the powers, and then you have x raised to the power of 3. Is that correct? So we are going to be applying the first law of indices to reduce any power of imaginary sign to its least level. Alright? So I hope you understand that. What is I raised to the power of 2? I raised to the power of 2 is negative 1. So we just put this here and then this is minus 1 multiplied by I, and then when we multiply this gives us minus I. Remember, so it shows that anytime you are given I raised to the power of 3, the least result is minus I, which happens to be the second result here. I told you earlier that whenever you are given I raised to the power of n, the outcome will fall out to be any of these 4 results. It's either this, or this, and then this, right? Okay. Now take for instance you have I raised to the power of 4. In indices, this is I raised to the power of 2, then I raised to the power of 2. Or you can say I raised to the power of 2 squared using the fifth law of indices. You know, the fifth law of indices said that if I have something like this, is the same thing as s raised to the power of a times b, which is if I have s raised to the power of 2 into 3, and then this is s to the power 2 by 3, and then this is s to the power of 6. So I can either use this or this, any of the case. And then we understand that I raised to the power of 2 is minus 1, and then I raised to the power of 2 again is minus 1, and then this is positive 1. So it shows that I raised to the power of 4 is 1, positive 1. Now we'll do this to 10 and then we can solve many others. So if I have I raised to the power of 5, I can extend this as, let this be your benchmark. Don't forget, this is our benchmark. Our benchmark. So what will I do? First is to find a way to reduce this guy to an even number. If I do this, this is same thing as I raised to the power of 4 multiplied by I raised to the power of 1. Alright? Remember that this is dot so that we can be able to extend this to its least level. Okay? And then this is equal to I raised to the power of 4 is 1. You understand this, right? Or otherwise, maybe you don't want to go with this. This is our benchmark. Remember that I raised to the power of 4 is the same thing as I squared raised to the power of 2 into an extension. 2 multiplied by 2 gives us 4. And we know that I raised to the power of 2, let's get this off the track. So we know that this is equivalent to what? Minus 1 squared multiplied by I. And remember that minus 1 squared is positive 1. So 1 times I, this would have given us I. That's it. Now the same thing if I have I raised to the power of 6. This is I raised to the power of 2 into. Remember, using the fifth law of indices, if I put 3 here, 2 times 3 give us 6. Why do I leave this inside the bracket? Because I already know the value of I raised to the power of 2. And then what's the value of this? This will give us minus 1 raised to the power of 3. And now, anytime a negative value raised to the power of an number, the outcome becomes negative. So this automatically will give us minus 1. That's the answer to this. Minus 1 times minus 1 multiplied by minus 1. All of these will give you negative 1. You can actually test on this with the help of your calculator. Are you there? Now again, if I have I raised to the power of 7, this will give us I raised to the power of 6 into I. This will give us 7. Remember, we are applying the laws of indices. So these are the power of 1. 1 plus 6 is 7. Now I already know the value of this, which is this. And then I can actually use my benchmark, which is the standard I raised to the power of 2. From I raised to the power of 6, I can get I raised to the power of 2. Is that correct? So how do I get this? This is actually equivalent to I raised to the power of 2 raised to the power of 3. Remember, I just break down this. Why am I doing this? Assuming I am not given a question to solve for this, and this, and then I'm just given 7. I don't need to solve for all of these rules. I only need I raised to the power of 2. So that's why I'm solving this question now as though there is no existence of I raised to the power of 6. Okay? So how do I break this down? I raised to the power of 6 can be given us I raised to the power of 2 or raised to the power of 3. And this will give us I raised to the power of 6. Then multiply by this I. Alright? So I raised to the power of 2 is negative 1. Raised to the power of 3, and then this is I. Now remember that 1 raised to the power of 3 will give us negative 1. Negative 1 raised to the power of 3 will give us negative 1. And negative 1 times I will give us negative I. Now at this point, I want to move on to higher powers. And then take for instance, I have I raised to the power of 18. It's the same thing. All I need to do now is I want to teach you another basis to solve this. Now listen, I want to teach you another concept that will actually help you. You see this power. You pay attention to whether the power is even number or whether the power is odd number. When the power is higher, so unlike we have now, this case the power is higher, right? Now when you have this, and then all of these ones you didn't have them, you didn't calculate for this to this level, but you are just given I raised to the power of 80. How do I solve this? So what you do with higher power is to check whether the power or the number is even number or odd numbers. So if it is an even number, all you just need to do is to divide it by 2. So this is an even number. If I divide 18 by 2, I will have 9. So all I need to do is just to have I raised to the power of 2. Divide 18 by 2, you have 9. Put the 9 outside. 2 times 9 gives us 18. Of course, I already know the result for I raised to the power of 2, which is minus 1. And then this is 9. Now, minus 1 raised to the power of odd number will give me a negative result. So I'll have negative 1. It's as simple as this. Now, again, if I have I raised to the power of 25, this is equivalent to. Now, what will you do here? Now, listen carefully. If I check this power, we are solving this based on the fact that there is no existence of all of this. Okay? Let's just assume this is the only question you are given. So you don't need to start calculating from 1, 2, 3 to 24. You can just go ahead and do this. So what will you do? Check the power. When you check the power, see whether the power is even number or an odd number. If it is an even number, divide by 2. But if it is not an even number, look at the theory. Reduce the power to its equivalent even number. So now, anytime I have an odd number, if I add 1 to it, I will get an even number. And equally, if I remove 1 from it, I will get an even number. What I'm trying to say in the lesson is that this is 25. If I say 25 plus 1, I have 26, which is an even number. And then, if I have 25 minus 1, I have 24, which is also an even number. But on this note, we do not add, we only subtract. Okay? So when you find out that the number is an odd number, what you do is to remove 1. So when we remove 1 from this will give us I24 into R. Remember, this is power 1. This and this will give us back 25. So how do I solve I raised to the power of 24? Because I don't really have much business to do with I raised to the power of 1. But this one that is greater than 1 is my major area of focus. So because this is an even number, all I just need to do is to divide this by 2. If you divide 24 by 2, you have 12. So what we are going to have now is that this is I raised to the power of 2 raised to the power of 12. Everything I have here now is for 24. Then multiply by our R. I hope you understand what I'm doing here. I raised to the power of 24. Break it down by dividing it by 2. I raised to the power of 2. So if we divide 24 by 2, we have 12. Put the 12 outside here. Using the fifth law of indices, which I stated earlier that it is possible to have A, B as x to the power of A multiplied by B. This is the fifth law of indices. This is possible, right? So this is what we are applying here. So when you multiply this, you get back to 24. But understand, why am I doing this like this? I place emphasis on this so much. This is because I already know the least value for I raised to the power of 2, which is what? Negative 1. So this will have given us minus 1 raised to the power of 24 raised to the power of 12 all into R. Now, minus 1 raised to the power of 12. Remember, 12 is an even number. So whenever negative 1 is raised to the power of an even number, the outcome is positive 1. So that means everything that we have here is 1. 1 times I will give us positive I. This is just all about the basis. Now, take for instance, we want to examine the concept of 99. I raised to the power of 99. This is giving us. Again, you will check this number. This number is not an even number, but an odd number. So what will you do to odd numbers? You remove 1 from odd numbers. So if I remove 1 from 99, this will have given us 98 multiplied by what? I. You can decide to also put this in brackets. The product of this will give us 99. Can you see this? Now, if this is clear enough, what else will I do? Already, I know that this 98 is an even number, a number divisible by 2. So I will simply divide 98 by 2. And if I divide 98 by 2, guys, what will I have? I'm going to have 49. So this automatically becomes I raised to the power of 2 all raised to the power of 49. Then multiply by I. I hope you understand why we are doing this. This I raised to the power of 2 will already have a default value, which is minus 1. So what we need to do now is to put in minus 1 raised to the power of 49 multiplied by I. And then after obtaining this, we move ahead to this. Now remember, this is minus 1. So minus 1 raised to the power of 49. Being that this 49 is an odd number, our outcome here will automatically become minus 1 multiplied by I. And minus 1 multiplied by I, we have this as minus I. Remember, as I did mention earlier, that when you find I raised to the power of n, and n can be any number, your outcome can either fall out to be I, negative I, 1, or negative 1, which are 4 possible outcomes. Are we there? So now we're going to look at other areas and then we are going to go. I hope you have gained massive values already. Okay, now let's examine this. Take for instance in an exam, you have something like this. Evaluate I raised to the power of 150, then evaluate I raised to the power of 187. So we start with number 1, I raised to the power of 150. Alright? So if this is an exam question, the first thing that will just comes out from your mind is that I raised to the power of 2 is minus 1. This is all you need to solve any problem in complex number when I, which is the iota, is more than 2. So if this is clear, all I need to do is to find a way to introduce this guy into this model. So how will I do this? I will check this number. Is this number an even number or an odd number? Clearly, this is an even number. And what do we do to even numbers? We simply divide even numbers by 2. So we can introduce these 2. So if we divide this by 2, what do we have? We have 75. 150 divided by 2 is 75. So this will give us I raised to the power of 2 or raised to the power of 75. It's as simple as that. So remember, if you multiply this back, you're going to have 150. Using the fifth law of indices, power law. And then all we just need to do, what is I raised to the power of 2? That is actually negative 1. And then this will give us minus 1 raised to the power of 75. And then if this is clear, minus 1 raised to the power of odd number will give you negative 1. So as long as the power here is an odd number, the outcome will be negative. So this will give us negative 1. It's as simple as this. Now, and again, we were given I raised to the power of 187. 187. Now, and we are asked to solve this. Remember, this is where this other guy stops. And we are asked to solve this. How do we solve this? Remember, I raised to the power of 2 is negative 1. Then, how do I introduce this guy into this? Now that I know that this power is an odd number, I will first of all reduce it to an even number. So I will remove one I from this. And if I remove 1 from this, we will have this as I raised to the power of 186 multiplied by I raised to the power of 1. The product of this will give us this back. We have taken the first step. Then the next step is to reduce this. Now, we have no business with I. Our business is I more than 1. This is I raised to the power of 1, or this is I raised to the power of 186, which is more than 1. So how do we get this done? We now divide 186 by 2 because it's already an even number. So when we divide 186 by 2, we are going to have this as I raised to the power of 2 multiplied by this guy divided by 2 will give us 93. I hope you are there. As simple as this. Then into I. And again, listen carefully. From what we have here now, as you can see, my I raised to the power of 2 is negative 1. So I just introduce this here. Negative 1 raised to the power of 93. And then this is equal to I raised to the power of 1. Now remember that minus 1 raised to the power of an odd number will give us negative 1. So automatically this is minus 1 multiplied by I. And then by the time you multiply this out, our result becomes minus I. This is the least value of all of this. So even though you are given I raised to the power of 997, it is the same way. Reduce this to an even number, but I 996 multiplied by I. The same way, if you are given 9I raised to the power of 8819. You check this number. Is it an odd number or even number? Since it's an odd number, you have this as 18818.I. Then you can divide this by 2. It's very, very simple. So no matter the power of imaginary sign that you are given, guys, you can actually solve these problems effectively without wasting your time. All that you need to know about reducing the power of iota to its least level is that I raised to the power of 2 is minus 1. So when you have this key, you can unlock any problem under this condition. So without further ado, we are going to apply this trick to solve some basic problems very, very shortly. Alright guys, as you can see, we have the very first question on the board, and then we are asked to find the value of the following. We have A and B. Then the Roman figure 3C, we are asked to express this in the form this, which is very, very simple. So these are the possible problems you can have using the power of I. So as I have this now, what will come up in my mind is, oh, this thing is very, very difficult, complex, and that. Not complex. All you need to do is to understand simple principles. So let's begin this. Let's call this a solution. Like I said, anytime you are dealing with a question that involves the power of iota, I, or the imaginary sign, more than 2, all you need to recall is I raised to the power of 2. So the first thing you need to do now is to say recall that I raised to the power of 2 by standard is -1. So for every problem here, my interest is to reduce any of these I raised to the power of n to their least level. I will say that the least level of I raised to the power of n, this can guide you through. I raised to the power of n is equal to plus or minus I, or plus or minus 1. So any of these powers of I that you have here now, in their least level, will fall out to be either any of these 2 or any of these 2. Remember, these are 4 results all together. So this is the first basis, or the first thing you should remember. Having stated this, then we can start picking these questions one after the other. Now, Roman figure 1, for question number A, we're given that Z is equal to 1 plus I10 plus I20 plus I30. So, how do I solve this? All I need to do is to say where I10 is equal to, I20 is equal to, and then I30 is equal to. So how do I find I10? You see now what we are trying to explain before now. So because I have I raised to the power of 10, and the power is big to some extent, more than I raised to the power of 2, what will I do? I will divide this by 2. Or first, check if the number is divisible by 2. Of course, all the numbers that we have here, they are all even numbers. And all even numbers are numbers divisible by 2. So if we divide 10 by 2, we will have 5. So by extension, this is I raised to the power of 2, all raised to the power of 5. And this is I raised to the power of 2 by standard is -1. And -1 raised to the power of 5. And then when -1 is raised to the power of 5, you can use your calculator to confirm this. The answer is -1. It shows that anywhere I have I raised to the power of 10, I'm going to substitute -1. It's as simple as this. Then again, when we come over to this is equivalent to the same thing we're going to do. 20 divided by 2 will give us 10. So this is I raised to the power of 2, or raised to the power of 10. By the time you multiply out, you get about this. And then I raised to the power of 2 again is -1. Then we put in -1 here, or raised to the power of 10. And then when -1 is raised to the power of 10, which happens to be an even number, the outcome turns out to be +1. It's as simple as this. Then finally we have I raised to the power of 30. So I raised to the power of 30, 30 divided by 2 will give us 15. Then we have I raised to the power of 2 raised to the power of 15. And then I raised to the power of 2, guys, is -1. Then we have -1 all raised to the power of 15, and then all is equal to -1. Remember, when -1 raised to the power of an odd number, the outcome is -1. You can confirm this with the help of your calculator. If this is clear, guys, all we need to do now is to substitute these values here, and then we simplify. That will be the answer. Therefore, Z is equal to the first here is 1, plus the value of I10 is minus 1, plus the value of I20 is 1, plus the value of I30 is minus 1. It's as simple as this. Then automatically this will have given us 1, minus 1, plus 1, minus 1. Everything here gives us 2 minus 2, then this is 0. So that means the result for adding up all of these components is 0. That's all. This is just all about question number 1. Now let's look at question number 2. Number 2, we have B, and then we are given that Z is equal to 2I10 plus 8I6 plus 5I4 plus 2I2. This is the question. Remember, our basis of solving this is that I is the power of 2 by standard is minus 1. So all I just need to do here, I raised to the power of 2 is minus 1. I'm stating this here again because I have it here. Then the next is, you can I raised to the power of 10. We have done this before. You can just repeat what you have here, or you can work it out. Divide 10 by 2, you have 5. So this is I raised to the power of 2, I raised to the power of 5, and then this is minus 1 raised to the power of 5, and the outcome is minus 1. Then when we move down to I raised to the power of 6, and this again is an even number. So what do? We simply divide this by 2, and that will give us 3. So this I2 all raised to the power of 3, and then this is minus 1 raised to the power of 3, and then this is also minus 1. Then finally we have I raised to the power of 4. I raised to the power of 4 is I raised to the power of 2 all raised to the power of 2. Alright? Just divide 4 by 2, you have 2. 2 multiplied by 2, you have 4. And then this is I raised to the power of minus 1 all raised to the power of 2. And when a negative 1 is raised to the power of an even number, the outcome is positive 1. And this is positive 1. It's as simple as this. All we just need to do now is to substitute these values into this equation, and then we are good to go. Good to go. Good to go. So if this is clear, then we have Z is equal to 2 into I raised to the power of 10 is minus 1. So we have minus 1 plus 8 into I raised to the power of 6 is also minus 1 plus 5 into I raised to the power of 4 is positive 1. Then plus 2, I raised to the power of 2 is negative 1. So all we need to now is to clear off the brackets by multiplication. This multiplied by this will give us negative 2, then negative 8, positive 5, and then negative 2. So we can decide to collate the negative values. Minus 2, minus 8 is minus 10, and then minus 3 is minus 12. So automatically, this is 5 minus 12. And finally, our result becomes minus 7. This is the answer to this very question. So guys, you see that it is very, very, very simple. So all you just need to do is to understand how to reduce I raised to the power of any number at all to its least level. Remember, principles are what makes you principal, right? Now, finally, we are now asked to express this in the form of A and this. This is already giving us a concept in advance that our outcome will be in terms of real and then an imaginary. We're going to have real and then imaginary. So let's work this out and see if our outcome will actually turn out to be something like this. Okay, we have number 1. The question is, let's say Z, let's Z, C. Let Z be equal to 8, I3 plus 6, I16, then minus 12, I11. So this is what we have. How do we simplify this? The same way we treated this and this is the same way we are going to treat this. So first we are going to reduce this. reduce this and reduce this. Then substitute that endpoint results, right? So what is I raised to the power of 3? So I raised to the power of 2 is negative 1 multiplied by I, and then this we have as minus I. We are done with I raised to the power of 3. Then we have I raised to the power of 11 or 16. I raised to the power of 16. Understand that 16 is an even number. So what do we do to even numbers? We simply divide the even number by 2. And if we divide 16 by 2, we have 8. So this is equivalent to I raised to the power of 2 or raised to the power of 8. And then what is I raised to the power of 2? Negative 1. We have negative 1 or raised to the power of 8. And automatically, when a negative 1 raised to the power of an even number, the outcome is positive 1. Then we have this as plus 1. This is the outcome for that. Then we have finally I raised to the power of 11. Again, we understand that I raised to the power of 11. 11 is an odd number, and the number is such that it's not divisible by 2. So what do? We have to reduce it to a number divisible by 2 by simply removing 1 from what we have. So if we remove 1 from 11, we have 10. So automatically this is I raised to the power of 10 multiplied by I raised to the power of 1, which will give us 11, right? If we expand. Now I raised to the power of 10 in its least level is I raised to the power of 2 or raised to the power of 5. I remember I'm just trying to be fast here because we have done justice to I raised to the power of 10 countless times in this part, right? Then I raised to the power of 2 is negative 1, and then we have negative 1 or raised to the power of 5 into I. Are you there? And automatically, when negative 1 is raised to the power of an odd number, the outcome is negative 1. And then negative 1 times I, we have negative I. So this is all about that. Are you there? Now, all we need to do now is to make sure we substitute these results into this given expression, right? Then we have Z is equal to 8 multiplied by I raised to the power of 3, guys, is negative I. Then plus 6 into I raised to the power of 16 is positive 1. Then minus 12 into I raised to the power of negative 11 is negative I. So all we need to do now is to clear up the bracket by expanding this expression, right? And then if we expand this, we have this as negative 8I plus 6 multiplied by 1 is 6, and then minus multiplied by minus is positive. Then we have 12I. Now, in complex numbers, there is possibility of adding real to real, and there is possibility of adding imaginary to imaginary. Similarly, you can subtract real from real and then subtract imaginary from imaginary component. These are some of the things we are going to be looking at in the next module, which you can get access to if you check the description of this video, which is the basic operations in complex number. Are you there? So now, in this case, let's quickly rearrange this. We have 6 as the real part plus 12I, then minus 8I. I just rearrange this, taking this imaginary part to meet with this other imaginary part. Then we have this as 6. When we remove 8 from 12, we have 4. Then this becomes plus 4I. This is the result we have. Remember, you cannot add imaginary part to real part. This is actually what makes this a complex number. Are you there? So take for instance, this is what we have, and then if we compare what we have to what we are given, we find out that we are in line. The question says that we should express this in form this. So take for instance in this, and then you are asked to find what is A, what is B. In this case now, when we compare this to this, A is actually equal to 6, and then B is equal to 4. This is all about solving major problems on complex number. It's actually very, very simple solving this problem. So let's look at one more question before we dive into lesson 2. So as you can see now, guys, this is question number 2, in line with what we solved a few minutes ago. Are you there? Now we are asked to simplify this. Meaning, solve this to a level where you have your highest power of I as I to the power of 1. This is what it means. So how do we get to this level? This is solution. I can simply say let Z be equal to 10I3 plus 6I13 minus 12I10. Something like this. So all you need to do is to recall that I raised to the power of 2 is equal to -1. Of course, I do not have I raised to the power of 2 here, but I will need it to reduce I raised to the power of 3 to its least level. I will need it to reduce I raised to the power of 13 and 10 to their least level. This is it. Then, how do I get I raised to the power of 3? I raised to the power of 3 will be equal to I raised to the power of 2 multiplied by I raised to the power of 1. And then this is equivalent to I raised to the power of 2. We understand that it's -1. And then multiply by I. And our answer becomes -I. So anywhere we see I raised to the power of 3, we will simply substitute -I there. Are you there? Now you have I raised to the power of 13. Again, 13 is an odd number, so we cannot actually solve this directly. So what do? We simply need to reduce this to an even number by removing 1 from 13. And if we do that, this will have given us I12 multiplied by what? I1. This will give us 13. I12 is now an even number, so how do we deal with this? We divide 12 by 2, and then we have 6. So equivalently, this is I raised to the power of 2 or raised to the power of 6, then into I. Hope you are following me with this, right? Now, what is I raised to the power of 2? -1. In its level. Then we have -1 raised to the power of 6 into I. Now, understand that when -1 is raised to the power of an even number, you have a positive 1. And 1 multiplied by I, we have positive I. So anywhere we see I raised to the power of 13, we will put in I. As simple as this. Then finally we have I raised to the power of 10. And then we have done justice to this countless times. So this I raised to the power of 2 all into -1 raised to the power of 5, and everything here will give us -1. This is it. So all we simply need to do now is anywhere we see I raised to the power of 3, we put in the value. Anywhere we see I raised to the power of 2, we put in the value. Anywhere we see I raised to the power of 6, put in the value. It's as simple as that. So we have that Z is equal to 10 into I raised to the power of 3 is -I. And then plus 6 into I raised to the power of 13 is I. And then -12. I raised to the power of 10, like we have it here, is -1. All we need to do now from this level is to expand, remove the bracket, and we have Z is equal to 10 multiplied by -I. We have -10I. This multiplied by I, we have plus 6I. And then -12 multiplied by -1, we have positive 12. As simple as that. Now remember that there is a law that has it that you can either add or subtract imaginary part from another or real part from another. So from the level where we are now, we have 3 terms, of which 2 out of these 3 terms are imaginary components. So that means we can combine the imaginary components to give us a singular result. Are you there? So -10 plus 6I will actually give us -4I plus 12. And then by standard, we understand that for every complex number, remember this is complex number already, a combination of real and imaginary component. The real component must come first. So we have that Z is equal to 12 minus 4I. This is the outcome to this very question. So guys, we have been able to learn what complex number is, what is complex number. We'll be able to examine the concept of conjugate of a complex number. We have been able to look at the power, positive power of an imaginary sign, which is the iota. Then also we have been able to apply the imaginary power concept to solve various problems in complex number. We are done with the first module of this lesson. So very quickly, we are diving into the next module, where we will start looking at operations in complex number. Remember, what we have done so far is just a basic introduction to complex numbers. So we are diving into the major content in the next module. Guys, you can check the description of this video and then you will find the link to that very video. Now guys, if you have been watching this content from the beginning to this level, it shows that you have actually gained massive value. For this video to have captured your attention to this level where we are, it means this video is actually educative. So all you need to do is to subscribe to this channel if you have not done so, and ensure you hit the notification bell so that whenever we upload mind-blowing content, you will be notified. Don't forget to like this video, don't forget to share this video, and don't forget to leave a comment at the comment section. Do all of this and you encourage us to do more videos to educate your mind. Remember, this is Master Leaders. Get the keys and we deliver the keys to you so you can gain mastery over any topic. So remember, we have given you the opportunity to request for any video content you want us to make to cover some areas you are having issues with as far as calculation courses are concerned. Love you guys. Thank you for watching. See you guys in the next video. Like I said before, don't forget to check the description of this particular video. Love you from the Wise Masters team.